This video is on conditional probability. First, we're going to talk about the fundamental counting principle. Question states that how many different outfits could you put together using 2 sweaters, 4 pairs of pants, and 2 pairs of shoes? So what we have here is we have 2 sweaters, 4 pants, and 2 pairs of shoes. We want to create outfits. So what we would look at is a mapping. We would have 2 sweaters, so I'm going to use S's for sweaters. We have 4 pairs of pants, so I'm going to use P for pants. 4 pairs of pants, and we have 2 pairs of shoes. I'm going to use H for shoes, just because I don't want to use S's again. Now I need to figure out how many outfits I can make with these 3 things. So I'm going to start with this first sweater. I'm going to figure out all the possibilities I can make. So I can make an outfit with this sweater, this pair of pants, and this pair of shoes. But I can also make an outfit out of this sweater, this pair of pants, and then this pair of shoes. So that's 2 outfits I can make right now because of this line over here. Now I can do the same thing with this next pair of pants. I can make 2 outfits with these sweaters and pants and these shoes. That's 4 now. Do the same thing down here. That's 6. And I can do the same thing with this first sweater, the last pair of pants, and both pair of shoes. That's 8. So I actually can make 8 outfits just from this first sweater with all the pants and shoes. But I also have to do the same thing with the other sweater. So I'm going to do the same thing. So I have a sweater with this pair of pants, pair of shoes, pair of shoes. That's 2. Now I have with the second pair of pants, pair of shoes, pair of shoes. That's another 2. Pants, pair of shoes, pair of shoes. That's another 2. Pair of pants, pair of shoes, and pair of shoes. That's another 2. So that's another 8. So together, I would have 16 total outfits. 16 total outfits that we could make. So the fundamental counting principle says, suppose there are, let's go with A ways of choosing one item. So there are these 2 ways of choosing a sweater. And let's go with B ways of choosing a second item. So there are 4 pants. And then C ways of choosing a third item. So there was 2 pairs of shoes. Then the total number of possible outcomes is just A times B times C. So it would be whatever that number is, the number, which is your A, times the number, which is your B, times your C number. So you're going to put them into spaces. So it's A times B times C, the number times number times number. So that would be 2 times 4, which is 8, times 2, which is 16, the same answer. So instead of having to make out a map of all this, because sometimes it can be very long and tedious because you might have some huge amount of numbers, you can actually do the fundamental counting principle and just knowing how many spaces there are and how many numbers would go in each space. So for example, suppose a license plate can have any 3 letters followed by any 4 digits. So how many spaces are there total? There's 3 letters and 4 digits. That's 7 spaces. So there could be 7 spaces. 1, 2, 3, 4, 5, 6, and 7. 7 spaces. We're going to multiply all of these spaces because that's the fundamental counting principle. Now the first 3 are going to be letters. So I'm going to put an L for that. L for letters. And then the last 4 will be numbers. So I'm going to put a number symbol. Alright, so how many letters are there possible that you can have? There are 26 letters possible in the alphabet. And then for the next one, it doesn't say anything that you can't repeat them. So it can be A. So there are still 26 letters. 26 letters. Now, how many digits are actually possible? A lot of people try and say that there's only 9. There are 10 digits. You have 1, 2, 3, 4, 5, 6, 7, 8, and 9. but then you also have the 0 as well, because that's how you create the 10. So there are still 10 digits for all 4 of these spaces. So now we just multiply them. If you multiply them, you get 760,000 possibilities. So I'm gonna rewrite that. 175,760,000 possibilities. That's how many license plates can be made. And in North Carolina, we actually have this setup. This does not include the ones that you can make your own design for. Now part B, so using the same information, how many license plates are possible that have no repeated letters or digits? So there's still 7 spaces. 7 spaces. We're still going to multiply all the spaces. Now, because we can't have anything repeated, this number should actually get smaller because we can't have anything repeated. This showed us that we could have all of them repeated. This could have been AAA 0000. But now, we still have our 3 letters in front. Still going to have 3 letters. We're still going to have our 4 digits. The first spot can be any of the 26 letters. But now I can't repeat the letter, so I have to go down to 25. I can't repeat either of those 2 letters, so now I have to go down to 24. Now we're in the numbers. Now there are 10 digits that we can originally choose from. Now I can't repeat that number, so I have to go down to a 9, and then an 8, and then a 7. Now we just multiply all those. This time, we get 78,624,000 possible license plates. That's because we can't repeat any of the numbers or letters. Now this next one says, what is the probability? Probability is a fraction. It's going to be a number between 0 and 1. That a randomly selected license plate. So how many license plates do we have total? We have the 175 million license plates. Has no repeated letters or digits. So our denominator is our total amount of license plates that we have. That's at 175 million. Then we want, which ones do we want? We want the ones that have no repeated letters or digits. So our denominator is actually the whole amount of license plates. So a randomly selected license plate. That's that 175,760,000 license plates. And our numerator comes from the ones that have no repeated letters or digits, which is that 78 million. So 78,624,000 license plates. So to 3 significant figures, we would round that to 0.447. That's the probability of us getting one of the non-repeating letters or digits out of all of the license plates possible. This next one is slightly different. It says I have 5 books I want to arrange in a particular order on a shelf. So how many different ways can I arrange them? I have 5 books, so that means I have 5 spaces. But because I said it in a particular order, it means that if I put a book here, I cannot put it anywhere else. So I have 5 books that I can put here. We're going to multiply all of them. I have 5 books I'm allowed to put here, but now I only have 4 books that I can put in this next space. Now I can only have 3 books in the next space, and 2 in the next, and 1 in the last. This is actually, when it has 5 times 4 times 3 times 2 times 1 all the way down, this is actually called 5 with an exclamation point. This is called a factorial. This is called 5 factorial. This is something you'll see in later on in another math class. But it's called 5 factorial. It's actually in your calculator. So there are, when you multiply all those, that's equal to 120 possible outcomes. Because it says in a particular order. because it says it in particular. I can't put this book somewhere else if I want it to put here. So on this one, what if I only want to arrange 3 of my 5 books? How many ways can I do this? Well, that means I only have 3 spaces, but I still have 5 books that I can pick from. So I still have spaces, but I only have 3 spaces. Still going to multiply them, but I have 5 books I'm allowed to potentially put here. So I would put 5. Then I'd still have 4 books to pick from for here. Then I would have 3 books to pick from. Because I don't have the 2 and the 1, I can't call it a factorial. I would just do 5 times 4 times 3, and that's equal to 60. So this is very similar to what we did up here. There are 5 books I'm allowed to put in the first spot. There are 4 books I'm allowed to put in the second spot, and there are 3 books I'm allowed to put in the third spot. So I have 60 total combinations I can have. This is the fundamental counting principle.